Okay, now let's start with the operation on set. For the operation on set, you're going to start with addition and subtraction. Now, for the addition and subtraction of set, also work like addition and subtraction of algebraic expression, where we stated that we can only add or subtract like terms. In otherwise, we cannot add and subtract unlike terms. What do we mean by like terms and unlike terms? Let's say that, so I'm taking you to algebraic expression briefly. Let's say that if I have a plus 2a, this are, or these ones are like terms. Why are you saying they are like terms? This is a, this is a. So they are like terms. So you can easily add them. So when I'm adding them, I just consider the coefficient of this a, the coefficient of this a. We all know that the coefficient of this a is 2, right? Then the coefficient of this a is 1, but normally we don't write it. So if I have to add this one, 1 plus 2 is 3, then the a. What do you mean by unlike term? If this side is a and this is b, this is unlike term because I can't add them. A plus b is unlike term. But this is a, this is b, they are not the same. When you say something is unlike me, they are not the same. Is that okay? It's the same idea that you are going to apply to do our set. Is that okay? Good. So let's look at the first example here. Let's have a question like add 3 root 5 plus 4 root 5. Is that okay? Now here we have to add 3 root 5 plus 4 root 5. How do you identify this alike set? You can only identify it by looking at the numbers under the roots or the radical sign. So in this case, if I take roots, this root here is 5. Here too is root 5. You see they are the same. Since they are the same, you can say they are like terms, so you can add them. So when you're adding, just like the A, B, C, the algebraic expression, you are adding the coefficient. The same thing here, we add this and that. So here I'm going to have 3 root 5 plus 4 root 5. So it means that I'm going to add the 3 towards 4. Then I'll take one of the root 5. 3 plus 4 will give you 7 root 5. So this is how we add them. So when they are not like terms or the ones under the radical signs are not the same, there's no way that you can add or subtract. Is that okay? Good. Let's just look at another example. Let's look at this example 2. Okay. So we have to simplify 5 root 2 minus root 18. How do I simplify this? This is very simple to do. But you realize that here is root 2, here is root 18. So I can't subtract this from this because the one under the radical sign here is not the same as the one here. So you have to make sure that the one here will be the same as this. So you have to pass through some expansions and simplification before you can reach that. So if I have this, I have 5 root 2 minus root what? 18. Is that okay? Now we know that root 18 can be expanded or expressed as 9 times 2. 9 times 2 is 18. So here I have 5 root 2 minus. Now here I can, because it's times, we know that if I have root A times root B, I can write it as root A times B like this. So I can write this one in the form of this. Have you seen it? So here I can write this one as root 9 times root what? 2. Good. So here gives us 5 root 2 minus, now root 9 is 3 times root what? 2. So I have 5 root 2 minus, now 3 times root 2 will be 3 root 2. Now you can see that looking at the simplification I've done so far, the roots are the same. So I can subtract by writing it as 5 minus 3 root of what? 2. And this will give us 2 root what? 2. Is that okay? Yes. So now let's look at another example. So the next point or the next example is saying that you should simplify root 5 plus root 20 plus root 7. Okay. So let's see how you go about it. So this will give us, we have root 5 plus root 20 plus root 7. Now, this is root 5, this is root 20, this is root 7. You have to make sure that the one under the radical sign become the same. But nevertheless, this root 5 and this root 7, there's no way you can make it look the same. Is that okay? It means that when you're adding, some of them might not be like 10, so you leave it as it is. But this root 20, you can change it so that the radical here becomes either root 5 or root 7. So let's see what you can do about it. So this is root 5 plus, now you know that 20 can be expressed as 4 times 5 plus root 7. So root 5 plus root 4 times root 5 plus root 7. So we have root 5 plus root 4 will give us 2 root 5 plus root 7. Now this one, the coefficient is 1. So normally we don't write. So we are going to have 1 plus 2 root 5 plus root what? 7. So this will give us 1 plus 2 will be 3 root 5 plus root what? 7. So this we can't do anything about it. So this is how far you can simplify it. Is that okay? Now let's look at the last example, and you also look for some examples and try on your own. Okay, good. So now let's look at example number 2. Example 4. Root 50 minus root 200 plus root 98 equals k root 2. You have to find the value of k squared. Okay, so let's see how you can go about this. So this is root 50 minus root 200 plus root 98 equals k root 2. Root 50 can be expressed as 25 times 2. 25 times 2 will give us 50. And root 200 can also express as 100 times 2. 100 times 2 give us 200. Then root 98 can be expressed as 49 times 2, okay, equals to k root 2. 49 times 2 gives us 98. Okay. Now this root 25 can be written as 25 times root of 2 minus root 100 times root of 2 plus root 49 times root of 2 equals to k root 2. So root 25 is 5 times root 2. Root 100 is 10 times root 2. Root 49 is 7 times root 2 equals to k root 2. So 5 times root 2 is 5 root 2 minus 10 root 2. This is 10 times root 2. Then 7 root 2 equals to k root 2. So this is what you are going to get. Looking at this one, the roots are all the same, root 2, root 2, root 2. So we can add and what? Subtract. So first one, let's add first 5 plus 7, right? You're going to have 5 plus 7 minus 10 root 2 equals to k root 2. So looking at this one, 5 plus 7 is 12 minus 10 is 2. So here gives you 2 root 2 equals k root 2. So by comparison, you realize that here is root 2, here is root 2. So it means that k will be what? 2. So k is equals to 2. So k squared will be what? 2 squared, which will be equals to what? 4. Therefore, k squared is 4. Very good.